Hello and welcome back to the History and Philosophy of Science in 6 Easy Steps. Are you seeing how these steps fit together or why they're organized like this? Keep thinking about that as we go into week 4. What I'd like to do today is a quick recap of week 3, some feedback on that, try to kind of give you some tips for your revisions for some of the week 3 assignments, and then introduce week 4, which is going to kind of be a little gear shift for us. We're going to be shifting gears just a little bit in week 4. In week 3, of course, we looked at the philosopher Karl Popper, who's the second main philosopher, the second philosopher of science that we're going to look at in depth. And just to sum up his ideas, I'd like to use a summary that was written by one of you, actually. And that is that Popper's criteria were that a scientific theory should forbid things from happening, it should attempt to refute itself, and it should not make reinterpretations. So let's go into a little bit more depth here. Forbidding things from happening. So basically, for a theory to be scientific, it has to make specific predictions about the world, and in doing so, it's going to forbid the opposite from happening. So, for example, the theory of gravity is going to forbid something like this. I'm holding a stone, and I let the stone go, and it just hangs in the air. Okay, that is forbidden by the theory of gravity. So the theory of gravity is very scientific in this sense. It's very easy to test. And if I hold a stone up in the air and I let it go, and it just hangs in the air, then I have just falsified the law of gravity as we know it today, at least according to the way we're talking about Popper here and his ideas. Attempting to refute itself. So this is really what science is all about. Science is all about doing experiments to continually attempt to refute your theory, to refute your hypothesis. I really like this way of looking at the scientific method. You know, in school we talk about the scientific method as having, 5 steps or 6 steps or whatever it is, question, hypothesis, design an experiment, and so on. I really like Popper's method. It's much simpler. Conjectures and refutations. Conjectures and refutations. That is the scientific method, according to Karl Popper. You make a hypothesis, and then you attempt to refute it. You make a hypothesis, and you attempt to refute it. And I think you'll find that this simpler way of looking at things kind of brings in a lot more activities that we consider doing science than just the standard kind of laboratory experiment procedure. And thirdly, here we have that we can't be making reinterpretations. So this brings in the concept of what happens after a theory is tested. What do his practitioners do? If they're going to be scientific, they're going to accept that falsification and abandon their theory. That's it. Now, if they're not going to be scientific, what they're going to do is make, after the fact, ad hoc interpretations. They're going to try to introduce fudge factors. They're going to make explanations for why it didn't work in this case. Like, okay, so the stone didn't fall this time. It's hanging in the air. They're going to start inventing other things. They might even have little fudge factors, like maybe the law of gravity doesn't work on Wednesdays a week after the full moon or something like that. So that's the idea. We're not going to make reinterpretations if we're going to be scientific. And as far as using this, so we can use these criteria, this criteria which we could basically sum up as falsifiability, right? A scientific theory is falsifiable. It has to be able to be proven wrong. We can apply it to things like astrology, and they make predictions, and a couple of you tackled this in your essay on pseudoscience. They make predictions that are just so vague that they can't possibly be proven wrong, right? So you're sitting down across from me, and I'm your fortune teller, or your astrologer, or whatever, and I say, you've had great hardship in your life, and you're going to experience hardship in the future. You've been disappointed. Things like that. They're true about everyone, okay? And then as far as making reinterpretations, you'll find that this is very common. And this happened a lot. In fact, I'm getting ahead of myself a little bit here, but Thomas Kuhn talked about this. When adherents of a theory around the time of a scientific revolution, when they're confronted with the new paradigm, they will often, or when they're confronted with anomalies, they will start to make explanations. They'll make these kind of ad hoc interpretations to explain away the anomalies. So, for example, the phlogiston people, the phlogiston theorists, they said they noticed that when you burned a metal, it gained weight, and yet burning a metal like iron or magnesium, for example, was supposed to be releasing the phlogiston from that metal. So why would the stuff gain weight? So they started to make these kind of these explanations like, well, sometimes phlogiston can have negative mass, right? So we look at that and we say, that's kind of silly. But you have to kind of wonder sometimes how common that is. I mean, really, we all kind of make explanations to try to rationalize things when they're not fitting with our worldview, the way that we see things, right? So moving on then to the relationship between Popper and Kuhn, this is where I think you wanna focus in terms of the overlap between the two. Now, granted, and many of you pointed out, they're really looking at two different things. I mean, Popper was focusing on what is science, and I don't think Kuhn really even intended to address that question of what is science. He was looking at how does science progress through time? How does it change? What is that process? Whereas Popper was really focused, and he says very specifically, I was concerned with the demarcation between science and non-science. However, those two things brought them into very close contact at points, because really what Popper used to make the demarcation is his definition of how science works, right? And so that is very closely related to Thomas Kuhn. And I just pointed out one area of overlap, and that is in the concept of anomalies. What are these anomalies in Popper's view? So if Karl Popper was to look at these anomalies of Thomas Kuhn, where would he put them in his theory? Would they be the refutations? And then when the phlogiston theorist is looking at the increasing mass of the metal and not seeing it as a refutation of his theory, then what's happening then? Is he being scientific, right? So that's one place of overlap, conjectures and refutation. So I think, and I'm not going to give it all away because, or at least all my thoughts away, because I know some of you are going to be working on some revisions here, which is a good place to bring up some specific feedback about this week's work. A few of you are falling behind, so be careful of that. And make sure that you do the revisions. If I've sent you an email or if you have a 0 anywhere in the gradebook right now, that means you need to resubmit the assignment. And please, if you need any help, if you want hints, I'll give you hints. So just send me an email. I'll point you in the right direction for making some revisions on those assignments. As far as the forum discussions, I've been happy with that. I'd like to see more participation, and don't forget that you all have to reply to someone else. You will not get credit for that discussion activity until you've replied to someone else. And again, encouragement to get on Twitter. It's nice for us to discuss among our classmates, but it's really cool to just throw it out there to the whole world. You never know who might see your post on Twitter or comment on it, especially when you put the hashtag science. It really makes it kind of a global discussion, or has the potential to be that way anyway. Okay, so think about that. Okay, as far as the graphics, I was very pleased with how they turned out. They're all, everybody who submitted their graphics so far is off to a great start. I think everybody has to resubmit though, because they were missing, and again, it's very important to read the rubric. The rubric says that you have to have a thesis for this. I know maybe it seems a little weird, but that means there needs to be some sort of a summary statement on there, or a conclusion written on there that kind of sums the whole comparison between Kuhn and Popper up into, say, one sentence. And this can be challenging, but I think some of you are onto it. Some of you have picked up on the key differences and similarities here between the two. So real quickly, I'd like to do kind of a little critique of Karl Popper. I think he made a huge contribution. I love this idea of conjectures and refutations. But I think if you read on into section 3, in particular, in the essay, you were assigned to sections 1 and 2. If you read on to section 3, he starts talking about something called induction. And I think what he does is he kind of sets a trap for himself in his philosophy. And I know it's kind of presumptuous of me to be questioning a famous philosopher on this, but I don't think I'm the only one who has, and some of you might have thought of this as well. He talks about something called induction and the so-called problem of induction. Now, the problem of induction was dealt with by David Hume in the 1770s, I believe, during something called the Scottish Enlightenment. We had a huge kind of burst of free thought and philosophical thought in that time period, which, by the way, we'll be getting into in week 4. But he thought about this thing called the inductive method. Now, supposedly there's these two types of argument. There's a deductive argument and an inductive argument. A deductive argument says this, therefore this. And so, for example, all Smurfs are blue. I am not blue. Therefore, I am not a Smurf. Right? That's deductive reasoning. It's watertight. Okay? All the information, the conclusion is actually contained in the premises. It just needs to be drawn out. Now, inductive reasoning is different. It says something like this: all swans I've ever seen are white. Therefore, all swans are white. So, every time I've seen a swan, it has been white. Therefore, the next time I see a swan, it will be white. Let me give you another example. Every time I've dropped a stone, it has fallen. Therefore, the next time I drop a stone, it will fall. That's inductive reasoning. Now, what Hume said is that's really not logically valid. Just because I've never seen a white swan doesn't mean that black ones don't exist, and in fact, they do. And just because I've never seen a stone not fall doesn't mean that there might not be a day when I let it go and it rises. Okay, so it's not logical. So that was what he called the problem of induction. Now, Hume has his own explanation for that. He basically says says there's really a psychological explanation for this belief that rocks will always fall, and it has to do with habit formation. But what Popper does, he disagrees with Hume, and he gives another explanation. He says it's really not just the habit that we get used to rocks falling, and so we come to expect it. He says that what we're really doing is we're always trying to refute things. So in other words, every time I let go of a rock, it is in effect a test. I'm making a conjecture that it will not fall, and then that it will fall, and then when it does fall, basically I just failed to falsify my theory. And so I become more confident in it. Now, here's the problem with that. And this problem, I think, is dealt with by another prominent philosopher called Michael Polanyi, and he wrote this book, Personal Knowledge, Towards a Post-Critical Philosophy. And I'll talk a little bit more about him and Kuhn in a second, and you might see some similarities here. He said a lot of things, obviously, in this book, but one of his main points was that as scientists and as people in general, a lot of what we think and the decisions we make are not all made for clearly thought out reasons. That there's a lot of kind of subjective stuff that goes on. For example, when we become convinced of something, how much evidence do you have to see to become convinced of something? How many times does something need to happen before you see a pattern? He gives an example like this. Say I look up into the sky and I see that there are 2 stars in a line. Well, that means nothing, right? Because any 2 points form a line. What if I see 3 stars in a line? Is something going on there? Is that random that there could be 3 stars in a line? Well, it's Orion's belt, and I think it's random. Now, if I see 4 stars in a line, am I going to say that something's going on there? What if I see 5 stars in a perfect line, am I going to assume that there's something lining them up, some force lining them up? What if I see 6 stars in a line? At what point will I be convinced that there's something else going on here, that it's more than just random chance? That, Polanyi says, has to be a subjective thing that's happening in our mind. The way our brain works, at some point it crosses a threshold and we start to see something else. We start to search for a cause, right? And at that point, of course, we could employ conjectures and refutations. We could make a conjecture, a theory about what's going on, and we could try to refute it. But the point I'm making here is that, here's my question for Karl Popper. How many times does a theory have to be falsified in order to abandon it? Just once? So when I let go of that rock and it hangs in the air, what if there was an explanation for that? What if it was a magnetic rock like magnetite, and at that point some experimental aircraft was flying over that had an extremely strong magnetic field and it held that rock in the air? And then because it happened just by random chance at that 1 second, that one moment, I throw out the whole law of gravity. Well, that shouldn't happen. Okay, well, then when is a theory falsified? How many times does the rock have to hang in the air before I can assume or I can conclude that the theory is really wrong? So it's not as clear-cut as he makes it seem. And I don't think that he adequately deals with it, at least not in the essay Conjectures and Refutations. So that's something to think about moving into the future. I think one of the things I like about Kuhn and Polanyi is that they bring in this kind of subjective element in the way that science works, and that it's not all logical and rational. It's a lot about what's going on in our heads, in our brains, as scientists. And speaking of Polanyi and Kuhn, there's kind of this debate going on. Polanyi and Kuhn have a lot of overlap. Michael Polanyi talks a lot about these subjective elements and what causes people to accept theories, for example. Like sometimes people will accept a theory before there's any evidence just because the equation is so beautiful, like E equals mc squared, for example, so elegant and simple. There's debate about who had these ideas first. Both the phlogiston theorists and Lavoisier were looking at the same data, remember, and they were just seeing it differently. One saw the data as falsification, the other didn't. And what makes the difference? It kind of hints that there's something that's not entirely logical or rational going on here. And Polanyi was really the first one to thoroughly to deal with that and thoroughly address it. And the interesting thing is that Kuhn, apparently he had actually seen some of Polanyi's or attended some of Polanyi's lectures. But in his first edition of his book, he didn't even cite Polanyi. And in his second edition, he cites him like once in a footnote, and it's just like a minor contribution. So it kind of harkens back to the Lavoisier-Priestley debate, doesn't it? All right, let's wrap this up. Let's talk about week 4. So in week 4, we're going to shift gears a little bit, and we're going to be focusing on history again, the history of science. But this time we're going to ask a couple of questions. One is, when and where did the scientific revolution occur? And you're going to start with a discussion of that on the forum or preferably Twitter. What I want to do is just get all your ideas out there, post some links to the answers and reasons, figures, pictures, graphs, whatever. And then I want to kind of tease out the location. We want to try to pinpoint the scientific revolution. And then secondly, we're going to actually try to answer the question of why did it occur there and then? Which is kind of a significant question, because when you think about this, this rapid increase in technology and scientific knowledge, it sure would be nice to keep that going, right? Or even to accelerate it if possible. So if we could answer this question of what were the causes of it happening there and then we could kind of encourage those factors, right? So there's some practical aspects to this question. So let's take a look at week 4. The influence of society on science, the European miracle. So I'm giving away some hints there, But we're going to look at the possible causes of the scientific revolution. And we're going to start off by a reading. Now this reading is kind of interesting. It's also by a non-Western scientist, so I think it'd be cool to get this perspective. The other thing is he deals with a lot of theories here of the causes, and so it's pretty comprehensive. So you're going to start by reading that carefully. Then you are going to, reading number 2 is not required, it's just a summary of the book Guns, Germs, and Steel, which is the topic of the required video. So this you have to watch. It's a full-length documentary about this book called Guns, Germs, and Steel by Jared Diamond, who has a very interesting theory of the causes of the scientific revolution and the so-called European miracle. So for part 1, we're going to try to pinpoint the scientific revolution. In part 2, you're going to do the reading, you're going to watch the video, and you're going to write an essay about the causes of the scientific revolution. Make sure you read the rubric on that. And then finally, we're going to have a discussion in the forum and or on Twitter about the causes of the scientific revolution. All right, so I think you'll find this interesting. It's kind of almost like solving a mystery, looking back in history to try to figure out what was going on at the time and what are some of the possible factors that were involved. Why did it happen here and then rather than there and some other time, right?